Hello, this is your lucky sir. Now we will discuss about photoelectric effect. It's of atomic structure, class 11. Fine. One very important concept of your physics actually. It is photoelectric effect. The ejection of electron from metal surface using suitable frequency of light. Using suitable frequency of light. Let us say this is metal surface. On this electrons will be there. When you are giving suitable frequency of light, some light is falling on this and electron will be out. Condition: using suitable frequency of light. Frequency must be matching. For example, to remove the electron, you need 10 kilojoules of energy. For example, okay, and you are giving exactly 10 kilojoules of energy. Required is 10, you are giving is 10. Yes, definitely electron comes out. Electron comes out, but with no kinetic energy. Just it comes out, बस बाहर आके बैठता है, बस उतना ही. If you are giving more than that, for example, you are giving 12 kilojoules of energy, for example, and you require 10 kilojoules of energy. So rest 2 kilojoules of energy will be converted into kinetic energy. So whatever the excess energy you are sending, that will be directly converted into kinetic energy. For example, you are giving 15 kilojoules of energy, 10 require, so rest 5 will be converted into kinetic energy. Very interesting for me. If you are giving 20 kilojoules of energy, 20 kilojoules of energy, and you need only 10 kilojoules. Now here two things will come into your mind, right? One is 2 electrons will come out. Otherwise, 1 electron will come out with 10 kilojoules of kinetic energy. This is right. 10 will be the kinetic energy, not 2 electrons. Okay, one simple example I will tell you. In your examination, the pass mark is, let us say, 40% pass mark. You got 90%, and your close friend got around 30%. 30% means fail, and you are almost topper of the class, 90%. Okay, now when you got 90% and your friend got 30%, you both are very close friends. Now you go to your teacher. Respected sir, please consider our case. He is my friend. From my percentage, can you give him 10% so that I will be at 80%, he will be 40%, so you will get pass. Then you say, your sir will say, very good beta, we need such students like you, we will transfer. Is this possible? Is this possible? No, never. That means your marks are yours only. So 20 kilojoules of energy means it is of only one radiation and is rated to only one electron. So even not 20, if you are giving 100 kilojoules of energy also, one electron only come out with 90 kilojoules of kinetic energy. So what we say finally here is, kinetic energy is directly proportional to frequency. As you increase the frequency, kinetic energy will be more, directly proportional to frequency. And the number of electrons ejected, if you want to remove more number of electrons, then this depends on intensity. If you want to remove more number of electrons, intensity should be more. That means more number of radiations should fall, each with the remaining required energy. So this is another important point. Number of electrons ejected directly proportional to intensity, kinetic energy directly proportional to frequency. Right? The formula is, whatever the energy you are giving, that is equals to work function, energy required to remove the electron, then kinetic energy. Or in place of E, you can write h nu. Here h nu naught plus kinetic energy. Kinetic energy is equal to, you can write h nu minus h nu naught, or equal to h into nu minus nu naught. Very simple formula. Very regular questions you can expect this from this formula, where nu naught is called a threshold frequency. In chemistry, whenever you get threshold, that means minimum required. Threshold frequency, the minimum frequency required to remove the electron is, kinetic energy is equal to h into mu minus nu naught. Two graphs can be asked here. One is kinetic energy and frequency. Kinetic energy frequency graph, when you are taking, the graph will be like this. It won't start from here, it will start from here. Till this point, the energy is utilized to remove the electron. So you can say this is nu naught, threshold frequency. then as you are increasing frequency, the kinetic energy will be increasing. Very important graph, very important graph, you need to remember. And second is kinetic energy and intensity. Kinetic energy is not at all related to intensity, so this will be a straight line. Kinetic energy is independent of intensity. Kinetic energy is directly proportional to frequency, but after some time, till this time, the electron is coming out. That means this is threshold frequency. So this formula, these graphs, if you remember, that is done. And one memory based point you can say, photoelectric effect is generally shown by potassium, rubidium, cesium. These metals are called photometals. Potassium, rubidium, cesium are photometals. From this, you can remove the electron very comfortably, very conveniently. And previous questions are like this. Work function is some 4 electron volt. The energy required, work function is 4 electron volts for potassium, 3 electron volts for rubidium, 2.5 electron volts for cesium, like this it is there, 5 electron volts per sodium, and 6 electron volts per lithium. Let us say these are the values, just example values I am saying, and you are giving exactly 4.1 electron volts of energy you are supplying. When you give 4.1 electron volts of energy, then you can say for these 3 it is enough. So these will show photoelectric effect. These 2 cannot. But if you are giving 5.2 or 5.3, all these 4 can show. This cannot. If you are giving a 6 or 6.2 or 6.3, all these will give you the photoelectric effect. If you are giving 2.1 electron volts of energy, none of them will give you. So these kind of questions also can be asked. How many of the following can show photoelectric effect like that? Done. Thank you.